This lecture is on Ohm's law. Ohm's law, we have electric cars aren't pollution free. They have to get their energy from somewhere. Now, a lot of people think that they are, but remember, whenever you drive an electric car, that electricity has to be generated somewhere, and it's usually from burning something like coal. Now, Ohm's law is fundamental to all of electricity. It is the #1 formula that you will use for the rest of the unit. It is very, very imperative when looking at circuits, when looking at power, and looking at series, parallel. You're going to use Ohm's law a lot. And so it is very, very important that you know the formula, the units of the formula, and you be able to manipulate it very, very well. Goals for this presentation. So students should understand the relationship between voltage and current and resistance, and you should be able to calculate any of the above using Ohm's law. Now, this lecture is very, very, very short. It is exactly one slide before we go through and go to the summary of the goals. It is this: Ohm's law equals V equals IR. Remember, voltage is equal to energy per charge. And then what you have here is you have current, which is charge per second. So you start to look at manipulating these things, and you can figure out what resistance is. But resistance is measured in ohms. So remember, V is voltage, which is measured in volts. I is current, which is measured in amps. And R is resistance, which is measured in ohms. So we've looked at all three of these individually. Now we want to put them together with V equals IR. So looking at this relationship, you can actually see how high voltage can be very, very dangerous because it generally produces high current. As you increase the voltage, you increase the current unless you have an equal increase in the resistance. So it explains why a danger high voltage signs does not give you the ability to say, okay, well, I'm just going to go grab the power line. So you see right here, this is a very, very simple formula, but it's very, very important for the rest of what we're going to do. You have a formula for voltage, you have a formula for current, and you have a formula for resistance. So don't be surprised if you see multiple examples where I say, okay, I give you the resistivity, the length, and the area, and the voltage, and I ask you to solve for the current. You've got to be able to bring in the old formulas and see what's going on. So hopefully you understand the relationship between voltage, current, and resistance, and that you'll be able to calculate any of those using Ohm's law. You should be able to calculate voltage, current, and resistance. Like we said, the majority of the work in this particular unit is in the examples. So I hope that you pay a lot of attention to the examples that are with you as you go through the question section of this module.